This is disgusting. Are you ready?
We're ready.
We got human subjects that were conscientious objectors to the Vietnam War. And every single day, they would remove the blue zoo suit and they would vacuum it. All the poop, all the pee, anything that left the human body was collected.
Welcome to Zoe, Science and Nutrition, where world-leading scientists explain how their research can improve your health. Christopher, thank you for joining me today. And it's such a treat. We've known each other, I think, for more than 5 years now. Wow. For our listeners, Christopher is one of the top nutritional scientists in the world, carrying out, a whole series of big interventional studies in humans, which are randomized controlled trials, which is very rare. He's been a longtime member of the Zoe Scientific Advisory Board, and he's also been one of the authors of a major review of protein requirements for Nutrition Review. So there's sort of no one better to talk about protein, which is one of the topics where we've had the most questions from our listeners and members of anything that we've touched on this podcast. So I think it's going to be a lot of fun. Thank you for being here with us.
Absolutely. This is a topic that is near and dear to my heart. Many myths to be busted.
Well, on the topic of myth busting, why don't we start with our usual quick fire round of questions from our listeners? And just to remind you, Christopher, the rules are quite simple. You can say yes, you can say no, or if you have to, you're allowed a one-sentence answer, but no more than that. And we know that this is the hardest thing for any professor to do, but are you willing to give it a go?
Yes.
All right, you've got the hang of it already. Okay, Christopher, will I die if I don't get any protein in my food?
Yes.
Do animals contain special proteins that you can't get from plants?
No.
Should we all be worrying about getting enough protein?
No.
Are protein shakes and protein bars healthy for most people?
Compared to a tablespoon of sugar, healthier, but I always say compared to what? Compared to food? No.
I told you it was hard for a professor to answer these questions. And the last question, can eating more protein help with weight loss?
No.
Okay, I think a lot of people are already going to be surprised. And I hope we're now going to unpack this in the rest of the podcast. Maybe we could just start at the very beginning. So I think most of our listeners will feel they know what a fat is, right? They're thinking of like an oil they cook with or butter or, maybe the fat in a piece of meat. And I think almost everybody feels sort of confident about a carb, right? It's like it's bread or potatoes or something like that. I think, however, if a lot of people are like me, they're actually quite unclear really what protein is, except, they're sure there's quite a lot of it in a piece of meat because, their mum always said, eat your meat and get your protein. So could you just sort of start at the beginning? What is protein and why do we need it?
Sure. So when it comes to fat and carb, that's really most of our fuel. When it comes to protein, it's more of our structure. So all of our cells and our organs and our hair and our fingernails, all of that is structural protein. All the enzymes that are in our body that catalyze reactions and make metabolism move forward, those are all proteins. Many hormones are proteins. There's actually a huge list of functional things that proteins do. And to take it to one next level, maybe this is helpful, maybe this is not. All proteins are made of 20 amino acids in the human body. And I like to think of them like Scrabble letters in the Scrabble board game or the letters somebody would put on the marquee of a movie theater. And for perspective, there's a couple of them that are only 3 amino acids tied together, which would be called a tripeptide, but that would be unusual. The largest one I know of is something called maybe Tintin. It's 35,000 amino acids strung together. Wow. In a specific
So you're saying,
chain.
I was thinking about this like words and these amino acids like letters, but you're saying these words can get really long and you need a lot of them. But fundamentally, you can make any word, like any protein out of just this limited number of these amino acids.
One could be a limerick, and one could be a haiku. It's just amazing how they differ in length. And what's critical is not only that the specific amino acids, one after another, be perfect. Like if you were spell checking your writing in a document, it would say, nope, that word doesn't work. So it has to be perfect. And then when the amino acids are arranged in a certain configuration, these long strings of amino acids twirl and twist and conform. They actually have to be side by side in just the right way. And if you change that and unravel them, which happens in your stomach with a low pH, it happens with heat, you inactivate the protein. And if it was going to have some functional purpose like an enzyme or a hormone, it no longer works. And now it's kind of just like fuel. Now you can just break apart the single amino acids and use them, but it can't function like it was going to. And that's why protein's so tricky. So many things that it does, so many ways to activate and inactivate it.
And so, Christopher, to make sure that I've got this, because that was a little scary what you just described, you're basically saying, we eat food with proteins in it, we break it down. There are like 20 of the potential like building blocks, like letters, which is what you're calling these amino acids. And then our body makes almost everything we're made of out of those like 20 letters in unimaginably complex sort of combinations.
I like the way you said that. And let me add one twist to this, which is pretty interesting. There's very few rare exceptions to this. But when you say eat an animal protein or a plant protein and it goes into your digestive tract, you can't absorb those amino acids into your body until you break them down to their single amino acid levels. And then you absorb them, travels through your body, reassembles them, can't remember where it came from. Oh, did this come from a cow? Oh, did this come from a pig? Oh, did this come from broccoli? No clue. It's like, oh, it's just this amino acid. I don't even care. It came from a supplement. Can't even tell. It's just the building block.
Got it. So this is like I ate Shakespeare or I ate a comic book. My body just breaks it down to letters. That just makes the protein sound even more important. I guess follow-on natural question about this is I think one of the things that we've learned on this podcast is that our body has this amazing ability often to swap carbs into fat. So it doesn't really matter what you eat always because your body will make what you need. Can't we just make these letters, these amino acids, when we need them?
Yeah, I bet you a lot of people listening have heard of essential and non-essential amino acids. I think it's a pretty non-essential question for all of your listeners, but I'm going to say it anyway. The idea is while carbohydrates and fats are circulating in your body, the basic structure of those is built on carbons of different lengths. And they have very complex metabolic pathways. And at certain points in carbohydrate metabolism and fat metabolism, you can borrow one of these molecules, put a nitrogen on it in the form of an amino group, which means a nitrogen with 3 hydrogens. An amino reflects this nitrogen portion. You can actually make 11 of the amino acids by borrowing something from fat and carb and putting this ammonia, amine group on it. And likewise, if you were breaking protein down because you had enough for the day, which I hope we get to later, because most people eat more than enough. If you take the amine, ammonia, nitrogen group off, you can put it right back into the carbohydrate or the fat metabolizing chain. And that works for 11 amino acids. For 9 of them, there isn't a specific place you can borrow it from in your body. And so since you need all 20 for just about every single protein that you synthesize, you also have to get the 9 essential ones. And essential simply means you can't assemble the whole thing yourself. You got
so to make sure I got that, Christopher, because it got a bit scary in chemistry again. You're saying there are these 20. Actually, we can make some of them ourselves, but actually, like I think you were saying 9 of them, we can't make them. So you've got to eat them. You have to get those 9 in order to do, essential things inside yourself. Is that? Did I get that? All right. So protein's really important. We need to get some. Let's talk about how much we therefore need, which was the number one question that we had as we were preparing for this show.
Okay. You're going to just have to stop me all over the place and get me to explain it in English because this will be harder. But basically, I'm going to take one big step back and say, if you've eaten enough calories for the day, you got enough protein. Just so stop obsessing about protein. Protein's in everything. All 20 amino acids are in all plant foods. Big myth to bust here. And all animal foods. So if you're simply getting enough calories with a reasonable variety in your diet, like if you only ate rice all day, you wouldn't get enough. If you only ate cassava all day, you wouldn't get enough protein, but you also wouldn't get a lot. You also wouldn't get enough of other nutrients. So let me tell you how people figured out how to get enough protein. This is disgusting. Are you ready? So
we're ready.
I got my PhD doctorate at UC Berkeley in California. And they were one of the sites that did some of the initial trials in the 50s, 60s to establish this. And the fifth floor of my building, Morgan Hall in Berkeley, was called the Penthouse. And we got human subjects that were conscientious objectors to the Vietnam War. And they volunteered to live up there in blue zoot suits. And the scientists would sequentially lower their proteins successively down to zero and give them just carbs and fats. And then they would raise the protein back up slowly in their diet. And every single day, they would remove the blue zoot suit and they would vacuum it for all the hair and skin cells that sloughed off during the day. They would collect all the poop, all the pee, all the nose blowings, anything that left the human body was collected. Now, we already talked about this nitrogen thing in protein. And the initial studies were interestingly called nitrogen balance studies. And instead of like analyzing amino acids in poop, analyzing amino acids in pee, analyzing amino acids in hair, if you just burn it all up and analyze the nitrogen, that's how much you can calculate how much protein left your body. And then because they were nutrition scientists, they were calculating the amount of protein or nitrogen going into the body from food. So they knew how much was going in and how much was going out. They raised and lowered it for each individual until they were in balance. But Jonathan, when they did this for a bunch of people, as you might imagine, what they found out is, oh my God, this person in the room needed more than that person in the room. And when they combined their data with a bunch of other folks who had done this same disgusting thing, they came up with, in math, get ready for this, a normal distribution curve, which means, a couple of people needed very little, a couple of people needed a lot. There's a bell curve. So there was an average in the middle. They did arrive at what would be the average. Okay. And it's called the EAR. It's very specific in this huge nutrition book, the estimated average requirement. Now, here's an important question for you to think about. When you want to come up with protein recommendations for the country, what would you suggest recommending? Would you recommend the estimated average requirement? Because if everyone in the country got exactly the estimated average requirement, by definition, how many people would be deficient? Half, because it's the average amount. If you only get the average amount, the half of you that are above average, not just intelligently, but from protein requirement, would be deficient. And so this happens in protein and all the vitamins and minerals, Jonathan. So when the US comes up with recommended daily allowances for protein, vitamins, and minerals, the standard approach is to take 2 standard deviations above the average. And in mathematical terms, that means you've picked a number that should be adequate for 97.5% of the population. And there might be a couple people in the tail that need even higher than that, but it would be so few that you're pretty safe recommending that amount. Now, not only is that amount adequate, but another math thing to keep in mind here is if really everybody in the US or the UK, wherever, got exactly that 97.5%, 2 standard deviations higher, how many would be exceeding their requirement? Oh, actually, like 97%. Now, 97.
So just to make sure I'm with you here, Christopher, because this is you're moving at some pace. You're basically saying that when they came up with the recommended amount for protein, they basically picked the amount that makes sure that almost nobody would have too little. And as a result, this recommended daily amount, which I've definitely heard from vitamins, right? And supplements, you hear that very often. But I think anytime you look on the back of a food label, again, I've definitely seen that for almost everything. It's actually the amount that means almost everybody needs less than that.
Yes.
And so if you're getting the recommended daily amount, you don't need to worry that you're not getting enough. Actually, in a sense, you're getting more than you need for almost everybody. So where does this take us?
Okay. And so what that takes us to is they came up with a number that said 0.8 grams of protein per kilogram of body weight should meet that. And so I have a graph and a table that I can't show you because we have a podcast here. But for a lot of people, that RDA level would be maybe 40, maybe 50, maybe 60 grams of protein if you're heavier. So I have some US data that shows how much protein people eat in the US. And it's pretty much double the EAR or double the RDA. Just eating food, not even trying. And so to me, it's sort of this American idea of, God, let's see, that's what the RDA is, but I know I'm above average. So let me make sure I get some extra here. And it's like, no, you don't understand the concept. It was built in to recognize that some people would need more. And as a nutritionist, when I teach students, I have to say, this is not an individual approach. You should not look at the RDA to see if you are meeting your individual requirement. This is a population health approach, so that if everybody were to get that amount, almost no one would be deficient. And just as you were a bit surprised, every time I tell that story, the audience I explain it to is a little surprised.
And so, Christopher, I am surprised because I've had this experience, and I suspect there's quite a lot of people who've had this experience. So like the first time I ever went to a gym, which is about 10 years ago, and I had a trainer say, this is what you need to do in order to get healthier, which is what I was interested in, and fitter. One of the first things he said is, oh, well, you need to eat more protein, and you need to eat at least a gram per kilogram of protein if you're going to get any benefit out of the work that you're going to do at the gym. Now that number, because I think you just said it was 0.8 grams per kilogram, was your recommended amount, which is like the maximum that anyone in the world basically needs. How did this happen? Why is there this controversy? Help me to understand why there's this pressure about feeling people need to eat more protein.
Sure. Okay, so let's think about that. So there are some flaws with this nitrogen balance study that I suggested. And so what happens in at least the US from all the databases I have is, and this is very consistent in all research studies that I look at, most people get about 16, 17, 18% of their calories from protein. It's so consistent, it's just amazing. And then you look at how many calories you eat to maintain your weight. And let's not go down this rabbit hole, but most people underestimate how many calories they eat. The data I have says women eat 2,500 calories a day and men eat 3,000. And I know a lot of your listeners are going to say, not me. I only eat 1,500 calories a day. We've done feeding studies where we gave people a certain amount of calories, and it's really 2,000, 2,500, or 3,000. If you take 16, 17, 18% of those numbers, people tend to get about 1.5 grams of protein per kilogram body weight without trying. They're pretty much getting double the RDA. So now here's what happens if you're in the gym getting that double the RDA, right? Okay, so it's probably the 0.8 grams per kilogram met your need for enzymes, hormones, fingernails, and hair. You went to the gym to lift weights and gain muscle. So you probably want more than 0.8 grams per kilogram per day so you can put muscle on. Okay, so let me tell you how many extra grams of protein you need. So Jonathan, how ambitious would it be to put on 22 pounds or 10 kilos of pure muscle in 1 year? Would that be pretty good?
That I have to say sounds quite ambitious. I think if anybody saw me, they would say, totally ridiculous and impossible. But let's go with ambitious, shall we?
Okay, ambitious. So 10 kilos, actually 70% of your muscle is water. So if you were going to do that in a year, all you'd actually have to accumulate is 3 kilos of extra amino acids, or 3,000 grams of extra amino acids. Divide that into 365 days of the year, and just roughly, that means you would need an extra 10 grams of protein a day to retain, in addition to meeting your maintenance needs to put this on. Now, it's not quite a fair number, because when you're in the gym lifting and working out, if you're working out really hard, you're actually breaking down some muscle using those amino acids, and you have to replace them. So put another 10 grams on that. Say you needed an extra 20 grams a day, every day for a year to put this on. In the US, people are eating like 30 or 40 extra grams a day over that 0.8 gram per kilogram every day, just eating food. And one more tidbit I have here is, when you're working out hard every day, don't you eat more? You do. You don't eat just 2,000 calories. I have a Stanford football player who was in one of the Rose Bowl games. He was eating 5,000 calories a day because they work him so hard. He was getting 260 grams of protein every day without trying. He wasn't having shakes. He was just having food. So we should go to like which foods have that protein. But if we could go here, I have one more place to go is, well, wait, is that bad? What if you actually got more protein than you needed? What would happen to all that extra? Will it kill you to have more protein?
What happens?
Okay, but I want to go down a rabbit hole just for a minute for a fun exercise. So think, on an average day, you probably eat more carbohydrates than you need. And so once you've eaten some carbohydrate, the first thing it says, oh my God, does my brain need it right now? Nope, my brain's okay. Do my muscles need it? No, I'm doing a podcast with Jonathan. I'm just sitting here. I don't really need my muscles. Okay, well, I have a storage depot for my carbohydrate, and it's called glycogen. And there's some in my muscles and there's some in my liver. So I will try to fill up my storage capacity of glycogen, stored carbohydrate, so that I can have some later in the day. And do you know how long it would take you to deplete all the storage carbohydrate in your body? Any idea? Are you a runner, Jonathan? Actually, I don't know this, if you're a runner.
No, I'm very good at sitting in my chair doing podcasts, but tell me, how long does it last for?
So I bet you've heard that marathon runners at 20 miles bonk if they don't have enough carbohydrate. That basically means you've used up all the glycogen that you stored in your body. It's only about a kilo. Okay, let's switch for a minute to fat. So let's say you ate more fat calories for the day and you used it for various things, and mostly you burned it for energy. Where would you store that, and how much could you store? And I'll save you the trouble here. You can store an infinite capacity of fat. Oh my gosh, you can store hundreds and hundreds and hundreds of pounds of fat in your butt, in your thighs, in your jowls, in the pads in your fingers. Endless capacity to store fat. It would take you an incredibly long time to use up all the storage of fat that you have in your body. So unlimited capacity to store fat, a very limited capacity to store carbohydrate. Where could the extra protein go? So your trainer told you to do this. You ate all that extra protein. You made your enzymes, you made your hormones, you lifted your weights, and it was a little more than you needed, or maybe a lot more. And you're going to bed tonight. So where do you think you put it in your body? Is it in your spleen, in your liver, in your big toe, in your elbow? Where's your protein storage?
Where is my protein storage?
None. Every bit of it at the end of the day has the nitrogen taken off, and it gets turned into carbs and fat. You can't store protein in your body. So the muscle heads who are having a lot of meat and regular meals and a protein shake and a protein bar are turning all that into carbs and fats at the end of the day.
And I'm just going to turn it into basically fat that I lay down on my body. Is that what you're telling me?
And the nitrogen will be taken off. Your liver will turn it into ammonia, and your kidney will excrete it and get it out of your body. And so you actually could suck out some calcium as it goes. And so some people say, don't eat too much protein. It'll suck the calcium out of your bones. Let's not go down that rabbit hole. It probably doesn't happen. Most people with a healthy kidney can eliminate this just fine. You might know that if someone has an impaired kidney, one of the first things they do from a dietary perspective is they ask them to limit their protein, because they don't want their impaired kidney to face the challenge of clearing more of this excess ammonia from the excess protein that most people get in a day. But to be honest, most people's bodies are set up to handle this, turn it into carbon fat and get rid of the ammonia. So for most people, eating that protein isn't necessarily bad for you unless you consider what came with it. So if this
I was just going to say, isn't this I feel like this is a huge scam. So basically,
yes,
there are all these products that are on sale that say, no carbs, 10 grams of protein, or, like no sugar, 10 grams of protein. And then you're telling me I eat it. I'm already eating more protein than I need. So my body is just going to turn that into carbs and fat. And since we know I already am eating as much food as I need, like if I'm having that on top, I'm just basically going to turn it into body fat. Have I got that right?
And so in the end, it all comes down to calories. So Jonathan, we just finished a fun little study with a master's student. We hope to expand on it. We got 22 Stanford graduate student recreational athletes who have been for 5 or 6 years working out every day. They're not competitors. They just work out all the time. They want to stay fit. 12 of them were runners. 12 of them were weightlifters. 6 in each group were men. 6 in each group were women. For 4 weeks each, we had them eat an omnivorous diet, a vegan diet, or these plant-based alternative meats. And the outcomes, instead of my usual cardiovascular thing with lipids or blood pressure or whatever, were push-ups, pull-ups, bench press, lat pull-downs, leg press, and for the runners, a timed 12-minute run to see how far you could run. And it was 4 weeks each. It's a preliminary study, but they were all kind of shocked. They ate much less protein on the vegan phase, and their performance was not different than in the omnivorous phase. They didn't lose any performance. And if you look, they were getting all the protein, as much protein as you needed by various athletic association type things. They weren't taking any supplements, no shakes, no bars, just eating a vegan diet. And another paper came out just this last month that someone sent me saying the same thing. And Stu Phillips, who's a fantastic exercise guy from McMaster University, he and I did a podcast together and said, yes, that 0.8 grams per kilogram number isn't right. It should be higher than that. It may need to be as high as 1.6. And I said, but isn't that what people eat anyway? He said, well, yeah, that's actually what they get anyway. So if you weren't getting that much, it's possible you could be impaired and you would benefit from this. But if you were tracking your calories right, and if you're eating a reasonable variety of diet, you wouldn't have to do what the trainer said to you. You wouldn't have to take any extra effort to get that amount of protein.
And Christopher, I think it's very clear. It's sort of amazing. I do want, however, to spend a little bit of time talking through sort of the different ages of people, because we had so many questions on social from our listeners about concerns about protein requirements at different ages. Yep. So I would love to start actually maybe with children. And I just have this sort of personal experience right now. So I have a 15-year-old and his friends have started drinking these new energy drinks that say they have added protein, which is a new thing for me. That wasn't what I wasn't even aware that was a thing. They've gone past caffeine. Is there any evidence that at this point, when you're growing really fast, that actually kids might not be getting enough protein and we need to really worry about that?
Yep. So for kids, if you go back to all those old RDA calculations, kids need not 0.8 grams, but at different ages, they need 0.9, 1.0, 1.1, because they're growing. Similarly, for a pregnant woman that's growing a fetus inside of her, she's not just maintaining, she's growing. And so those needs are higher than 0.8 grams per kilogram per day. The question is, can you get that just eating food? Or do you need to get these extra sources? And as I'm suggesting, the food supply, as long as you get a reasonable variety, and we should get into plant food versus animal food, but you would have to work really hard not to get that much protein. Jonathan and I attended the job talk of a nephrologist at Stanford who isn't a nutrition person, said, God, I'm trying to work with these people with impaired kidneys, and I've been trying to get them on this really severely restricted protein diet of 0.7 grams per kilogram body weight, and I can't get them there. And I laughed and I said, 0.7 grams per kilogram. It's severely restricted protein. That's practically the RDA. He said, yeah, I can't get them that low. I get them to try to eat this and that, and then I can't get them that low. It's hard not to get enough.
And so
protein.
Does that mean, as a parent, you don't really need to worry about it?
Well, isn't your refrigerator empty? So I have 4 boys.
Yes, he does eat a lot of food. There's no doubt.
They bring their friends and it's like, I skipped dinner. Really? Aren't you eating? Oh, no, I had like 2 pizzas a half an hour ago, but I'm skipping dinner. Oh, my God. And then I go out at midnight and he's having a sandwich. It's like bottomless pit. Now, if you go to the other end of the spectrum, there's possibly some issues with elderly because digestive tract, dentiture. So they're not chewing enough food. They've sort of lost their appetite. We have this issue of sarcopenia where they're losing muscle mass. There have been some studies. It's not really just the hormones. It's loneliness. It's depression. It's not eating. It could be that you have to make special effort to make sure in the small number of calories that they're getting that they are protein rich because they're just not eating very much.
So, Christopher, you've been very patient about not talking about where the protein comes from.
Oh,
so
thank you.
Let's do that. And we had lots of people asking us basically, sort of versions of the same question. Is animal protein better than plant protein? And, how are they different? And why is it that one might be better than the other?
Yeah. So you're killing me that this is a podcast because I can't tell you how many hours I spent making slides showing different amino acids. So at this point, we really have to get down to that amino acid level. And so I'm going to do my best to describe some of these slides I made, Jonathan. So if you look at the estimated average requirement of protein for a lot of people, it could be close to 40 grams of protein, which is pretty low. And I like to use that number just for fun to make this one point. There are 20 amino acids. If you need 40 grams of protein, simplistically, that sounds like it would be good to have 2 grams of each one. 2 times 20 is 40. Not even close. So you need tons of glutamate, glutamine, aspartate, asparagine. You need hardly any tryptophan, methionine, cysteine. And the best way I've found to describe this is the game of Scrabble. So Scrabble, which my wife beats me at regularly, is 100 tiles in a bag. And I don't know if you know this, from one country to the other, the distribution of letters is a little bit different depending on how often those letters are used in the language of that
I'm learning
country.
about Scrabble and protein now, Christopher, so it's great.
So think 26 letters in the alphabet. There's 100 tiles. Aren't there 4 of each letter in the Scrabble bag to make your words? No! There's only one Z, there's one X, one J, and there are a whole lot of E's and A's and N's and R's. Amino acids are just like that. So what I did is I sort of made a graph and I showed, here's the distribution of 40 grams of protein in eggs, in chicken, in pork, in fish, in beef. And the distribution is stunningly similar. And I say, wow, that's pretty interesting. All the animals have a lot of the same ones and a few of the same ones. And then I say, okay, so you've all heard plants are missing amino acids. Which ones do you think they're missing? Are different plants missing different amino acids? And I put up some fake data and I say, which one do you think is rice and beans and broccoli? And I don't let them think for long. And then I put up the actual amino acid distribution and their jaws drop. All of the plants have all 20 amino acids. The distribution of the amino acids is almost identical in the plants as the animal. And they say, what have been people telling me? Professor Gardner, are you lying? Did you make this up? Because this is not the reality that I've been told. And it's a very simple kind of trivial thing, Jonathan. So rice and other grains in general tend to be low in the proportion of lysine that they have relative to the optimal proportion. And likewise, beans tend to be low in methionine and cysteine in proportion to what they need. And so I like this Scrabble analogy. So picture that you've had this Scrabble game for a really long time and you lost the L for lysine and the M for methionine. Are you missing all the L's and all the M's? No, actually, you only lost a couple of the letters. So if you were using your board and trying to make words, you would run out of words you could make with L and M sooner. What if you had a neighbor who also hadn't played Scrabble in a long time, and they said, oh, I'm so sorry you're missing those letters. You can have my Scrabble bag of letters. Oh, I'm also missing an L and an M. I'm sorry. You could still fill up the L and the M that you were missing because your neighbor has extra L's and M's. And I think Americans eat at least 80 grams of protein a day, not 40 that they need. And so I'm thinking, what if you had 2 bags of Scrabble letters? Oh, that's like what Americans eat in protein every day. 2 bags of Scrabble letters. And if they're eating plant proteins, they are lower in lysine and methionine than would be optimal. But that's only a concern if they only get 40 grams of protein and they need every amino acid to count. But they get 80 grams of protein, even the vegetarians and the vegans.
And Christopher, just one clarification. I think that it sounds like in general saying, don't worry about this. Are you saying, because you're mentioning 2 particular amino acids that I can't pronounce,
Yeah.
Are you saying that in all plants, the relative amount of that is lower than it is in animals?
Yes.
So even if you're having a variety of plants, so it's not just that like one plant is low in the L and the other one is low in the M. Actually, on average, like all plants are lower in that relative to animals. And therefore, if you were eating a plant-only diet, then if you were going to eat the 40 grams of protein, you're going to have potentially a low level of those 2 particular amino acids. I just want to make sure that I'm...
Yeah, if you needed 40, it's not really that you need 40. You need 40 in the right distribution. If you only ate rice all day, that's how you got your 40 grams of protein. You wouldn't have enough. Even if you ate 40 total grams of protein, you run out of lysine too soon. If you only ate beans, you'd run out of methionine before you got enough. So you could supplement with just those individual amino acids, or you could eat 80 grams of protein a day, and you would end up getting the things that you're missing. Now, here's what happens. If you really only needed 40 and you ate 80, what do you do with the extra 40? You break 40 down and turn it into carbohydrate and fat. But that's typically what's happening, is that people eat more than the total amount they need. And so given that plants don't have the ideal distribution of the amino acids, they're almost always covered. And you just break down the other ones. So there is, Jonathan, an old concept that was written up in Francis Moore Lepay's Diet for a Small Planet about complementing your proteins, because the grains that are a little low in lysine are a little high in methionine. And beans are a little low in methionine, but they're a little high in lysine. And they say, this is sort of a no-brainer. That's why some populations ate grains and beans together, because they complemented the deficiencies with the excesses. It's still never quite as good as meat. It's still not the optimal distribution, but it's closer to optimal. So you can either try to complement them, or you cannot worry about it because you probably ate 80 or 90 grams and you didn't really have to think about it. So you can absolutely meet all your needs on a completely plant-based diet. Stop obsessing about protein. Thank you.
Brilliant answer. So let's say that someone's listening to all of this. You haven't managed to completely convince them that they shouldn't have protein, because it's hard to shake that. So they're saying, okay, but like I'm worried, or maybe I do fit into one of those categories that we're talking about where they are potentially concerned about it. What's the healthiest and tastiest source of protein that you would recommend?
beans, hummus, all the 3-bean soup, a 3-bean salad. So David Katz and some other colleagues and I wrote a paper called Modernizing the Definition of Protein Quality. And in it, we said, okay, so there's this one issue of the distribution of amino acids, perfect in animal foods, less than perfect in plant foods. There's actually an issue of digestion and bioavailability, and it is a little higher for meat protein than plant protein. But when people are eating meats, they're getting a lot of saturated fat, and they're sometimes getting hormones, and antibiotics were used to grow that meat, and there's no fiber in there. If you were eating beans and tofu and tempeh and plant foods, you'd be getting much less saturated fat. You'd be getting phytochemicals, antioxidants. You'd be getting lots of fiber for your microbiome. You guys at Zoe might have heard about the microbiome. That's a pretty cool thing. And so this idea of should the protein quality definition in the US is based on amino acid distribution and digestion and availability. And we proposed that it should also include the nutrients that come with those foods rich in protein, which in your bar was sugar, in that meat was saturated fat and no fiber, versus those beans and grains that had antioxidants and other things like that. And if we're going to be eco warriors these days and not destroy the planet we live on, the legumes and grains are much easier on the planetary boundaries of land use, water use, greenhouse gases, eutrophication, and biodiversity.
And I think, just to add on top, we discussed this just a few weeks ago. They're also incredibly cheap. You can buy them in cans. They last, and so which means you capture like all of those nutrients sort of at the point of picking, and then they sit there for months. So I think beans have had the worst possible marketing, probably because nobody can lock down the copyright in the same way as for that protein-enriched drink that my son was discussing with me a couple of weeks ago.
But I make a wheat berry salad with some nuts and whole grains in there, and I eat hummus all the time. There's plenty of ways to incorporate really fun Mediterranean, Middle Eastern, Latin American, South Asian dishes that really evolved around grains and beans. So there's just a global fusion of flavors out there for you. You do not have to look hard.
And your message is, even if you're trying to, be fast around the track or pumping your iron or all of the rest of it, you don't in fact need to be sort of eating a steak a day.
Eat food. Yeah.
Wonderful. Christopher, this has been an amazing tour. I would love to try and do a little summary, and then please keep me honest if I got anything wrong. Is that all right?
Ready.
Absolutely. Well, I think first you explained what is protein, and what I took away from this is like fat and carbs are like the fuel that power us through the day, but protein actually creates the structure. So like everything we're made of basically comes from these proteins, and that they come from these 20 amino acids, which I'd never understood what that was before, but now I've got in mind they're sort of like the letters in the alphabet, and then I'm like all these words that get created out of these letters. In terms of how much protein we need, the answer is far less than any of us realized or have been led to believe. Your colleagues at Stanford, a long time ago, did these crazy studies of people sort of wrapped up in suits to understand exactly how much they needed. And it turns out there's a lot of variation between people. And I'd love to figure out how we might be able to measure that at home somehow in the future. But at the moment we can't. Christopher's shaking his head. There's always some new technology, I feel, that maybe that will make it happen. But at the moment you can't measure that for yourself. But what they did is they figured out sort of what's the maximum that almost anybody needs. And that was actually only 0.8 grams per kilogram. And on average in the US, people are eating double that already, which means that they're eating, far, far more in fat than they need, so they don't need to worry about it. And then we talked about, well, what about if you're not eating lots and lots of animal protein? Is that a problem? And the answer was really not, that actually there are all the amino acids in plants. There are a couple of these amino acids which have lower amounts relatively, But since we're all eating so much of it, it's not really a problem. And I think the final point was almost anything that says like extra high protein on it, or, a bar or a shake or any of these things are just really bad for you. Don't eat them. And I think, Christopher, your message is eat beans instead.
Yep. Perfect. I don't know why it took me an hour to say all that when you just said it in 3 minutes, which is pretty good. There's one critical mistake. So those old studies in the blue zoot suits were Berkeley, my alma mater, not Stanford, my current place. And, there's a lot of competition between the two. I don't want to exacerbate that.
I can see that I'll be in a lot of trouble. You'll be in a lot of trouble there. So I apologize. Christopher, thank you so much. I think it was fascinating. And I think there's, a few of these points that I'm sure we could go into in more detail in a future podcast. But I certainly think you will have hopefully made a lot of people feel more relaxed, which is great. And also probably look very differently at these foods that say no sugar and 10 grams of protein, because they now realize if they eat that just before they go to bed, they might as well just have had a chocolate bar. It would have been more fun and you would have had the same result, which I had not previously realized. So probably don't do that at home.
Okay, great. It was very fun having this discussion. And I hope some people learned some things. Thanks, Jonathan.
It's such a pleasure. See you very soon, Christopher. Thank you, Christopher, for joining me on Zoe, Science and Nutrition today. If based on today's conversation, you'd like to understand how to support your body with the best food for you, including plenty of high-quality sources of protein, then you may want to try Zoe's personalized nutrition program. Your Zoe membership comes with meal and recipe recommendations, access to our nutrition coaches, and scientifically backed nutrition advice on how to eat for your best health, so you can feel more energetic and reduce the risk of chronic health conditions. Your personalized nutrition program is based on our scientific research and the results of your personal at-home test. If you're interested in learning more about Zoe, you can head to joinzoe.com/podcast and get 10% off your purchase. If you enjoyed today's episode, please be sure to subscribe and leave us a review, as we love reading your feedback. If this episode left you with any questions, please send them in on Instagram or Facebook, and we'll try to answer them in a future episode. As always, I'm your host, Jonathan Wolfe. Zoe Science and Nutrition is produced by Fascinate Productions, with support from Sharon Feder, Yella Hewings-Martin, and Alex Jones here at Zoe. See you next time.